Q8716. Aircraft pressure fueling systems instructional procedures are normally placarded on the A. Fuel control panel access door. B. Lower wing surface adjacent to the access door. C. Aircraft ground connection point. The correct answer is A. Proper identification and adherence to fueling procedures are crucial in aviation, particularly when using a fuel pressure fueling system. Instructional procedures for pressure fueling are typically placarded on or near the fuel control panel or access door to provide clear guidance. It is essential that only individuals who have been thoroughly trained and checked out on the proper procedures are allowed to fuel an aircraft with a fuel pressure system. This precaution helps ensure safe and accurate fueling, minimizing the risk of errors or accidents. Additionally, using the correct type of fuel is of utmost importance to prevent engine damage or detonation. Fueling an aircraft with the wrong type of fuel, such as turbine engine fuel in a reciprocating engine, can have severe consequences. Adhering to established procedures and receiving comprehensive training in fueling operations are vital to maintain the safety and integrity of the aircraft fueling process. Q8717. Pressure fueling of aircraft is usually accomplished through A. Pressure connections on individual fuel tanks. B. At least one single-point connection. C. Individual fuel tank overwing and/or fuselage access points. The correct answer is B. Pressure fueling of aircraft is typically accomplished through a single-point connection, which allows fuel to be pumped into the aircraft from a single location, rather than having to connect hoses to multiple fuel tanks individually. This method is more efficient and reduces the risk of fuel spills and contamination. Q8718. Which of the following may be used for the repair of fuel leaks on most integral fuel tanks? A. Welding and resealing. B. Brazing and resealing. C. Riveting and resealing. The correct answer is C. Integral fuel tanks are those which are a part of the aircraft structure, and the metal skin of the aircraft is welded or riveted together to form the tank. These tanks cannot be easily removed for maintenance or repair, and therefore, the most common method used for repair of fuel leaks on integral fuel tanks is riveting and resealing. Welding and brazing can generate heat that may weaken the structural integrity of the tank. Additionally, welding or brazing may leave behind contaminants, which could cause further problems in the fuel system. On the other hand, riveting is a relatively low-heat process that does not affect the structural integrity of the tank, and it can be performed without leaving any contaminants behind. Therefore, riveting and resealing is the preferred method for repairing fuel leaks on integral fuel tanks. Q8719. How is the outlet fuel pressure regulated on a submerged, single-speed, centrifugal-type fuel pump? A. By the engine-driven pump's design and internal clearance. B. By the first check valve downstream from the pump. C. By the pump's design and internal clearances. The correct answer is C. In a submerged, single-speed, centrifugal-type fuel pump, the outlet fuel pressure is regulated by the pump's design and internal clearances. This type of pump operates by centrifugal force, and the fuel pressure produced is proportional to the speed at which the pump is turning. The outlet pressure is determined by the design of the pump, including the shape and size of the impeller, the clearance between the impeller and the pump housing, and the shape of the discharge port. Therefore, the outlet fuel pressure is regulated by the pump's design and internal clearances. Check valves are used in the fuel system to prevent fuel flow from reversing direction, but they do not regulate the fuel pressure. Q8720. What is one purpose of a fuel tank vent? A. To maintain atmospheric pressure. B. To decrease fuel vapor pressure. C. To decrease tank internal air pressure. The correct answer is A. Fuel tanks need to have a vent to allow air to enter and exit the tank as the fuel is used, so that the pressure inside the tank can remain close to atmospheric pressure. If a fuel tank did not have a vent, as fuel was used and the volume of air in the tank decreased, a vacuum would form inside the tank, and this could cause problems such as fuel starvation, fuel pump cavitation, or even tank collapse. Conversely, if the tank did not have a way for air to enter as fuel was used, then the pressure inside the tank would increase, which could lead to fuel leaks or other problems. The vent also allows for the release of any vapors that may accumulate in the tank, helping to prevent dangerous situations such as explosions.